Alcohol. It's going to be a dot in a green circle. Carbon diamond. We're going to try crayons. Hey, sorry I'm late, gang. Today what we're going to do is continue our C-Star Memorial Lecture. We just missed C-Star too much. She died, today's the 17th of June. She died on the 7th of Monday. Nitrogen alien. These are amino acids. Today we're going to do sugars. So this is going to get a lot easier. The whole idea of sugar, what I didn't realize till after I had my degree and thought I'd seen it all, was that sugar holds water. There's a lot of alcohols. Now, if you remember, the photosynthesis is what's making the sugars. So in CO2 and water coming together, you're making something that is going to be polar. So they draw it in the books traditionally like water having the 2 protons and a delta minus charge up here. There's 2 lone pairs of electrons up there, actually. So see, for your general comparison here, they draw the molecules just lines, no lone pairs of electrons. But then when they draw the way it really looks in here, you'll see they're mixing. These are people that don't know what they're doing, and they're trying to just present it and say, look, it's in the book. The polarization, nitrogen here carries it too, the ammonia. So wherever there's that lone pair of electrons, that's why I say they don't draw it in there. But see, this is where the alien's head is, and that negative pair of electrons up there. Oh, and you know what's cool? It's negatively charged, so they're green. They're going to be little green men on top of the blue nitrogen to keep our color coding here. And see what they're doing? They're using red for oxygen. This right away shows they don't know what they're doing. They hire their artists to put it together. Today, our talk is on sugars. So we're going to do the Schroeder Diamonds on this. This was the way I drew it up originally here on my notes. So in black and white is the way they presented in the book. Well, we're going to throw the book out the window. We're going to draw glucose. That sounds like something a nurse would do, right? So to warm up on it, let's try our whiteboard here. The beauty of this, 4 colors, covers everything. Carbon's black, nitrogen blue, oxygen green, little protons red. To review our Schroeder diamond here, let's do, for example, we'll draw it from my notes here, see if I can mess this up. We're going to start with the oxygen, because what you'll see the book presenting when they show their sugars here, if you can see these close enough, they're just showing the OHs going up and down, right? Well, the oxygen up here makes this form into a ring. So you can draw this in the nursing books, they'll draw it like this. But in a water aqueous environment, it's going to be in a ring there because the water is going to push it around. So see fructose right here? This is an easy way to draw it. But it's really confusing because see, it's the side that the OHs are on is what you need to know for the chemical structure of this thing, because when they start forming together. So this is something that they memorize and they act like they know what they're doing because it's real easy to memorize for anybody with a half-intelligent brain, half-educated. So this, I don't like that structure. This is a lot more representative. They don't draw the lone pairs in. So watch how colorful we're going to make it. Sugar is usually considered to be glucose. So let's draw glucose. And what's it going to have? 6 diamonds. Now my point of this before was I'm going to start with the oxygen because we're going to put the oxygen up here. It's going to be making a ring out of this. So 6 carbons, the first thing this does here, we're going to try and keep this theme. We're developing it as we go, but whenever we get a carbon bond, we always want it on the side. So even if we have to crisscross on this, we're going to do it. So when it comes to the first carbon here, remember CO2 and water is what made the sugar from the photosynthesis, carbon, the oxygen. So each of these carbons now is going to have an OH on it. So we're still working on this. We have to draw another bond over here, but we want carbon to carbons are always going to be on the side. So we're going to draw this that way so that the next carbon has the bond on the side, and then the next one over here, see? If we keep doing it that way, it'll give us our structure, because the way these things are up and down and front and behind is really important now when you draw the three-dimensional structure of this thing. So we got 1, 2, 3 carbons. The real chemistry of this is where the oxygen goes. Well, in this case, they're not double bonded, so it's really easy. They're the alcohols. So if there's an up or a down, this is where the diamond comes in handy, because this here turns out to be a down, so we could just draw it down. And our alcohols, we're going to do this for simplicity. The less space we take up, the better, I think. So there's an alcohol group on the bottom. And what does this carbon get up here? Just a little dot. We come down here. Each carbon's going to have an OH on it. This one here gets it on the bottom. So we're just going to take that out of the way and start focusing here. This OH on the bottom. Look, there it is, right there on the bottom. The next carbon over for, what are we drawing here? Glucose. This one gets it on the up. So see here, this is already a teaching tool that is light years ahead of the old way they're doing it. So we come up here again, and what we want is the carbon bonded on the side, even if we have to crisscross like we did over here. But that'll be kind of cool, because when we get good at it, see, it gives it a three-dimensional structure. Kind of looks like a kite hanging up there, doesn't it? Okay, so we got 1, 2, 3, 4 carbons. There's one more carbon in the ring, so we could draw that carbon there, and then we know there's one up here, so we can even draw that way. So this, we're breaking our structure here, went to that. This has to go to the side, so we'll bring that one to there. And this is just up and down. So look at that. See how simple that is? 6 carbons we just drew. We have a three-dimensional structure if you look at this too. Can't you kind of tell how this is coming forward? And this kind of makes it go back. So this is great. I'm so proud that it came out this way that on the side. As long as the carbons are on the side, it gives you an up and a down on that front. So they're either pointing towards you or away from you. This is really, it's called stereochemistry. It's which way carbon with the 4 bonds can do this. So we're not finished with our OHs here yet. This here is an important carbon. This is what bonds to the next one when you do a chain. You see, like the book here, you've got the carbon on here, which this makes it the alpha carbon, they'll call it sometimes, going down. So when this one bonds on the side over there, that's this one. So this is an important carbon here with respect to where is the OH on it. And on that carbon, for glucose, it's going down. So see, we can draw it right there, going down. Up here, what happens? It really doesn't matter where the OH is on that, so we can just draw it on the side if we want. This one we can pick wherever we want it to be. So now, like we used to check the bonds, all the carbons have to have an O on it. So this carbon has an OH, this one has an O, that has an O, this has an O. What about this one? We can count that one for that. It's called an ether. When you get an oxygen in the middle, remember oxygen with 2 bonds. Well, out here the second bond is that hydrogen proton essentially. So we just draw the red inside for that. Draw those in. I'm going to get my pen all messed up here. But doesn't this look cool? I mean, it's just more artistic for people that want to make it look colorful. I mean, if it looks more colorful, it's going to be more appealing. It's going to be more fun. I think it's going to be easier to learn. And where did I just put the red? So now, after we got all our OHs, gets the one to come in and make sure there's 4 bonds on everybody. So this would be fun for a little kindergartner. Put the dots in there, Danny. Okay, there's 1. 1, 2, 3. That one needs 1. 1, 2, 3. That one needs one.